An exception is an unexpected event that occurs at runtime due to an error. Exceptions disrupt the normal flow of a program. If we had this snippet of code, it would compile. There would be no errors, there would be no warnings. However, when we run this, we run into an error when the loop attempts to access index 3 of this array because there is no index 3. So we receive an array index out of bounds exception, and the program would crash. You can handle exceptions within your code so that the program doesn't crash and so that you can provide a meaningful message. To do so, you use a try-catch clause. Let's look at an example. We're going to write a program that creates a new file, and we're going to handle exceptions that may occur. So here I have an exception handling class, and let's go ahead and make a call to a new method called createNewFile. And we'll make that method in the class. We're going to use the file class in Java to create a new file object. And we give it the path of the file. The file class has a method called createNewFile. So it can create this file if the resources directory exists, which it does not. So let's say file.createNewFile. Notice here, it's not compiling. If we hover over here, we see that it says unhandled exception. And it gives us the exception name that is unhandled, IO exception. So in order to handle this exception, we can place this statement in a try-catch block. So we type the word try, and we follow that with curly braces. And then we place the statement inside of the try block. We follow the try block with a catch. Notice that we have a compilation error because we don't have the catch block. Inside of catches parentheses, we have to specify the exception that we're going to catch. createNewFile has the potential of throwing an IO exception, so we want to catch what it's throwing. So we specify that, and we give this a name. In most programs, people just call this E or EX, something really short. After the catch, we also put a set of curly braces, and this is a block of code. So what happens is, Java's going to attempt to run this createNewFile. If an exception happens to be thrown, then we have provided a catch block. The code will come inside of here and execute everything in here. So we can provide maybe a print statement for our users. Additionally, when an exception is caught, that exception has a stack trace as well, which will provide information about the error and also the path that the code took before getting there. So you can print this out as well. If we do E, which is the name of the exception, dot, we see this print stack trace. There's also a get message that will show just the error message without the stack trace. So let's just choose the print stack trace. And we can run this. Notice here, here's our message. The directory does not exist. And then here is the stack trace. So it tells us the path that it took, started from the main, went to this createNewFile method, then went to files createNewFile method, and so on until it reached the exception. To handle exceptions, you can also use the superclass as a way to catch broader exceptions. If we look at the Java doc for this exception, we see that it inherits from a chain of other exceptions, with the top level exception class being exception. All exceptions inherit from the exception class. Let's take a look at our example. Here we're catching the IO exception because we know that that's what this is going to throw. However, let's say that this method threw more than one exception, or we weren't quite sure exactly what exception it was going to throw. Then we can use polymorphism, and instead of catching the IO exception, we can specify a superclass. Knowing that exception is the topmost superclass for all exceptions, then we can place that here. Doesn't have to be just exception. We can use any of the parents of that IO exception. There can be multiple catch clauses to handle different types of exceptions. If the multiple catch clauses contain related exceptions, the subclass's catch clause must appear first. Otherwise, it would never have the possibility of reaching other exception clauses. So let's look at an example. We're going to write a program that reads decimal numbers from a file. And then we're going to handle two types of exceptions that come from that program: file not found exception and input mismatch exception. So let's comment out this one, and we're going to make a call to a new one. We'll say numbers exception handling. And we'll create this method. Now in this method, I'm going to create a new file object. And then I want to read from that file. So I'm going to use the scanner object. And instead of system.in, we're going to use the file. So we're no longer reading from the console, we're going to read from the file instead. If we hover over here, we see we have an unhandled exception, the file not found exception. So let's place this in a try. Next, we want to read every line from the file. So we're going to use a while loop. And we're going to say while the file reader dot has next, and we saw this in the last chapter with iterators, read the number and then print that number to the console. Now technically we're okay. We weren't required to put this next double inside of a try block. However, there is a possibility that when we're reading from the file, if one of the lines in the file is not an actual double, then we would get an exception, an input mismatch exception. So we can handle the case of the file not found exception, and we can also add another catch block for the input mismatch. So now if either one of these exceptions is thrown, it will go into the respective clause. Now we haven't placed anything inside of these clauses yet. Let's say that all we wanted to do was print the stack trace. Then we could add that in both clauses. So let's say we also want to catch any other exception that occurs. And so we add a third catch block. And inside of this catch block, we say, go ahead and catch exception. Notice now we have a compilation error because exception is a superclass to file not found exception and also to input mismatch exception. So if any exception is thrown, it's going to first check this one. It's going to catch this one. There's no way that it will ever get to these two. So it's unreachable. Now we can still include this one, but it would have to be at the end of these, which means if there's a file not found exception, it'll go there. If there's an input mismatch, it'll go there. And then finally, if there's any other exception, it will come here. Now I'm going to get rid of this one. If we look at the two that we have, they're fine. This is okay, it works. However, there's some redundancy here. All we're doing is printing a stack trace. So it's kind of foolish to have both of these listed this way. We can simplify this by adding all of the exceptions that we want to catch into one catch block. The way we do that is by using the pipe symbol. So if we have file not found exception, we can use pipe, and then we can specify any other exception we want. So we can add that here. And you can add however many more exceptions you want, just separate them with this pipe symbol. So once we've done that, we can get rid of this catch, and this will catch either one of these exceptions. A finally clause can optionally be added below any catch clauses. This clause is executed after try and after any catch clauses, even if the catch clauses don't execute. Let's revisit the previous example and add a finally clause to close the file. So after all of your catches, you can type in the word finally. This one does not have a parentheses, but it does have the curly braces. So this finally block, you put whatever else that you want to do. So exceptions, they interrupt the flow of the program. So let's say, for example, we had the exception and it was thrown right here when we tried to instantiate scanner. Then it would come into this catch block. It would not execute the rest of this. So adding the close statement inside of here is not a good idea. Because if this exception is thrown, we'll come to this and this will never get executed. So the finally block says, hey, even if you finish everything in the try, even if no exceptions are thrown, I will execute whatever you place inside of me. So this will execute no matter what. If exceptions are thrown or if exceptions are not thrown, finally will execute. So anything that you just need to get done, you would place inside of the finally block. Now we have an error because this is out of scope. Remember, this is defined inside of only the try block. So we can fix this by declaring the file reader outside of the try block. So let's just do that. And we'll initialize it inside, and then the finally will close it. So that's just one way to handle this. We could also handle this without using a finally block. For example, there is an option that's called try with resources, which will allow you to add a parentheses after the try and then initialize the resource there. For example, this scanner object is a resource. So we could just add this set of parentheses and then define scanner there. Let me show you. And then we get rid of all other instances where we declared and initialized it. And once we have this defined at that level, we no longer need this finally clause. So what this will do, the try with resources allows you to specify a resource, and Java will automatically close this resource on your behalf once done with this try catch phase. Now this only works with classes that implement the closable or the auto closable interfaces. And scanner happens to be one of those. So that's an option when you're working with that kind of thing and you're only using finally to maybe close some resource. You could use this instead. Otherwise, you might have other cases where finally is a good approach to use to do some other statements, and that's fine as well. So you have multiple options here.